दिखेगा। यहाँ पर जाके app.jsx के अंदर बहुत कुछ लिखा हुआ था, तो वो सब कुछ हटा दो। हटा दिया, ठीक है, क्या दिखेगा? कुछ भी नहीं, कुछ भी नहीं, खाली व्हाइट स्क्रीन, ठीक है। भैया अब बताओ जल्दी से करना क्या है? क्या हो क्या रहा है यहाँ पे? होता किस तरीके से काम रिएक्ट के अंदर तो समझो। यहाँ पर जाके मैंने दोस्तों एक फंक्शन बनाया है, सिंपल ये आपको आता है। फंक्शन का नाम रखा है मैंने ऐप, आपको ये भी आता है। आपको ये आता है ना भाइयों? फंक्शन का नाम रखा है मैंने ऐप। अब मेरा फंक्शन जो भी रिटर्न करेगा, क्या रिटर्न करेगा भैया? जो भी रिटर्न करेगा, लेट्स सपोज़ मैंने करवा दिया तो हेलो रिटर्न हो जाएगा। क्या आपको ये समझ आ रहा है? मैंने यहाँ पर अपने ऐप के अंदर से हेलो रिटर्न करवा दिया, यहाँ पर हो गया। अब आप क्या करते हैं मैं आपको बताता हूँ, कुछ होती हैं चीज़ें जिसको बोलते हैं इम्पोर्ट और एक्सपोर्ट। आपको जावास्क्रिप्ट वाली वीडियो में बताया गया होगा, भैया ने बताया होगा कि इम्पोर्ट एक्सपोर्ट क्या होता है। इम्पोर्ट एक्सपोर्ट बेसिकली मैं एक फाइल से दूसरी फाइल में कुछ भेजना चाहता हूँ। तो मैं यहाँ पर क्या कर रहा हूँ, मेरा जो ऐप नाम का फंक्शन है मैं उसको एक्सपोर्ट कर देता हूँ। तो मैंने यहाँ पे लिखा एक्सपोर्ट डिफ़ॉल्ट, डिफ़ॉल्ट मतलब उसको डिफ़ॉल्ट जो भी टाइप है उसके साथ ही भेज रहा है। एक्सपोर्ट डिफ़ॉल्ट और मैंने यहाँ पे ऐप को लिख दिया। इससे क्या हुआ समझना, मैंने सब कुछ हटा दिया, मैंने नॉर्मली लिखा है सब कुछ, तो कोई दिक्कत नहीं होनी चाहिए ना। मैंने फंक्शन बनाया है ऐप नाम का जो कि रिटर्न कर रहा है हेलो और रिटर्न जो करा है उसने हेलो वो उसने कहाँ भेज दिया है, ऐप के थ्रू भेज दिया है, जो भी उसको रिसीव करना चाहे। और main.jsx के अंदर से यहाँ से हमारे पास ये लाइन काम की नहीं है। हमारे पास बस ये 2 लाइन काम की है जिसमें से रिएक्ट को इम्पोर्ट करा है और ये रिएक्ट डॉम को इम्पोर्ट करा है। तो सुनो क्या हो रहा है। यहाँ पर जाकर रिएक्ट डॉम के अंदर हमने क्रिएट कर दिया एक एलिमेंट डॉक्यूमेंट डॉट क्रिएट एलिमेंट बाय आईडी और यहाँ जाके गेट एलिमेंट बाय आईडी और रूट के अंदर इन्होंने ऐप को रेंडर करा है। तो समझो, हमको यहाँ पे आउटपुट में पता है क्या मिलेगा? हमको यहाँ पे आउटपुट में मिल रहा है हेलो। व्हाइट स्क्रीन के लिए सॉरी लेकिन हमको हेलो पता है कहाँ से आ रहा है? हेलो आ रहा है यहाँ से। यानी कि जो भी मैं यहाँ से ऐप के अंदर से पास करूँगा वो जाएगा मेन के अंदर और मेन के अंदर जो भी मैं लिखूँगा वो आ जाएगा इस रूट के अंदर। आपको ये समझ आ रहा है दोस्तों मैं कहना क्या चाह रहा हूँ? बढ़िया, बढ़िया। ऐप के अंदर से जो भी पास करता हूँ वो जाता है मेन के अंदर और मेन के अंदर जो भी मैं लिखता हूँ वो दिखता है किसके अंदर? रूट के अंदर और अगर आप आउटपुट देखेंगे, मैंने अगर इंस्पेक्ट करके देखा, तो यहाँ पर आपको देखने को मिलेगा कि हमारा ये जो एलिमेंट्स नाम का पैनल है उसके अंदर यहाँ पर बॉडी है और बॉडी के अंदर यहाँ पे एक रूट नाम का डिव बना हुआ है जिसके अंदर क्या लिखा हुआ है? हेलो। अगर मैं यहाँ पे हेलो की जगह लिखता, जय माता दी तो यहाँ पर आपको जय माता दी लिखा हुआ दिख जाता दोस्तों, कोई परेशानी है ही नहीं उसमें, जय माता दी लिखा हुआ आ जाता। समझ आ रहा है आपको क्या हो रहा है, जो भी आप रिटर्न करना चाहें। और हम लोग यूज़ कर रहे हैं दोस्तों जेएसएक्स और जेएसएक्स के अंदर आप पता है क्या कर सकते हैं? आप यहाँ पर जाके कुछ इस तरीके से जावास्क्रिप्ट के अंदर एलिमेंट्स बना सकते हैं, एचटीएमएल एलिमेंट्स जैसे कि मैंने एक एचटीएमएल पास कर दिया हेलो करके। तो ये जो हेलो है, ये पास होके कहाँ आएगा? मेन के अंदर और मेन के अंदर से ये पास होके कहाँ जाएगा? इंडेक्स्ड एचटीएमएल के अंदर और यहाँ पर हमको एक एच1 टैग मिल रहा है, यानी कि अब मैं रूट के अंदर देखूँगा तो मुझे एक एच1 टैग मिल रहा है। तो ये समझ आ रहा है दोस्तों क्या हो रहा है? आपको ये सच में समझ आ रहा है? अच्छा, तो भैया अगर मैं ऐप के अंदर हेलो ना पास करते हुए अगर मैं एक डिव पास कर दूँ, तो ये 2 चीज़ें पास कर
But have you also heard the saying, dogs of the same fur frolic together? Probably not, because I just made that up. But I hope this helps you remember that if you take more images of dogs and try to place them in the space defined by these two number lines, then you might have a dog here on the bottom left. Maybe this dog will be placed here on the right, and this dog here might appear somewhere on the bottom left, and this dog might appear over here on the bottom right. Notice that dogs with a similar amount of brown fur appear closer to each other, and dogs with white fur also appear closer to each other in this space. Now, in practice, we don't as humans choose these specific features for these number lines. Instead, we have machine learning models do that for us because then we get better results. Whenever you train a machine learning model to perform a task on an image, you get a fairly useful byproduct from this. For example, if you have an image classification model, you can give it an input like this, and it outputs a class, such as the text cute dog. In order for the model to perform this image classification task, it creates a representation of the important features that help it to decide that this is a cute dog. This representation is actually a list of numbers, maybe a few hundred to a few thousand numbers. And this is still pretty small if you consider that a photograph may contain 9 million pixels, which are 9 million numbers times 3 because there's red, green, and blue for every pixel. This list of numbers that a model creates to represent the image in a compact way is called conceptual understanding, as well as practical use of AI. So I'm not getting into the math here, but it's probably math that you've seen at some point in school. And since you may or may not want to relive your memories of math class, I won't get into it here. So let's just clarify the difference between image classification and similarity search with images. With image classification, if you give it the image of a dog, it will output some class, such as the text cute dog. In contrast, if you give an image to a similarity search database, then it will first create an embedding that represents that image with a small list of numbers. And then it can search through a database of other dogs, where each dog in the database has an embedding generated to represent it. Based on the distance between the embedding of the input dog and the embedding of each dog in the database, the similarity search database can retrieve a list of dogs that have the shortest distance between them and the dog being searched. So here's a quick quiz. Who gave the dog a name? The image classifier. And who let the dogs out? The similarity search database. Next, what if you want to go beyond a bounding box and identify every single pixel that belongs to this dog, or every pixel that belongs to this dog? To learn more about how, let's take a look at image segmentation in the next video. If you have any friends who are into photography, they may love to tell you how they can use a professional camera to blur the background in photos. If you don't have a professional camera yourself, you can still do that with your regular phone and AI. Let's see how that works with something called image segmentation. By blurring the background. For example, in Google Photos, you can click on Edit and then click on Portrait. Notice that it's blurring the image, but not the whole image, just the background behind me. So again, here is the original image, and here is the image with the blurred background. This is called the bokeh effect, and people like that it helps the viewer focus their attention on the subject of the photo. And don't worry, bokeh effect is not an AI-related word that you need to remember. Photographers love talking about the bokeh effect, so it's just a nice word to know in case you're friends with a photographer. The Photo app is able to identify specifically which parts of an image represent the person in the foreground, as opposed to everything else in the background on a pixel by pixel level. And by pixel, I'm referring to all the tiny little dots that make up a digital photograph. Here's what I mean. If you look at just a small section of the photograph and then zoom in, imagine if we zoomed in enough that we're actually looking at all the pixels that make up an image. It's essentially like a spreadsheet where every cell of the spreadsheet has a number that defines how much red, how much green, and how much blue is in that particular pixel. And in order to generate this portrait photo effect, the software attempts to identify for every pixel whether that pixel is part of the object in the foreground or is part of the background. So the ability to determine which pixel represents the person and which pixel represents the background is a computer vision task called image segmentation. Note, I am skipping over some additional processing that goes in order to identify the foreground versus the background, and this is called depth perception. But it is possible to just rely on image segmentation to create this portrait effect. So for now, don't worry about remembering what depth perception is. The output of image segmentation is actually going to be something that looks like an image with the same height and width of the original photograph, but where each pixel is given a value of 0 or 1. In this case, I'm representing the 1 values with the color white and the 0 values with the color black. But these can be any color for visualization purposes. The computer itself just sees a spreadsheet-like grid of zeros and ones. So a value of 1 indicates that a pixel from the original image is part of the segmented object, in this case the person. A value of 0 represents anything that was not part of the segmented object. In this case, that's the background. This image of just zeros and ones is called a mask. You can think of it the same way you think of a mask you wear for a costume. It outlines particular areas of the image, just like a mask that you might wear if you're a superhero or just attending some dress-up event outlines a certain area of your face. And this mask can then be used downstream for other steps in the software application to process just the pixels that are the person or just the pixels that are in the background. So here's what you can do to get the blur effect. So here's the original image, and here's the mask. And here is where we want to store just the pixels of the person in the foreground. For this pixel, let's say the value is 125. And in the mask, the value at that same location is 0. So 125 times 0 is 0. And let's put a 0 here. Let's try another pixel here. Let's say it's 150. In the mask, the value at the same location is 1. 150 times 1 is 150. So let's say that here. And if you do that for all the pixels, you'll get an image that has the same pixels of the subject, like this. And I'm simplifying a little bit for the sake of clarity. Normally, for color photos, every pixel stores 3 values, one for how much red, how much green, and how much blue, and that mixes together to produce the color. The next step is to go back to the original image and blur the whole thing. Yes, the background and even the subject in the foreground. Everything. I'll explain why in a bit. Then, take the subject that you carved out using the segmentation mask and overlay it on top of the blurred image. And that's how you get the nice portrait bokeh effect with a blurred background using image segmentation. Now, you may be wondering why we take this somewhat indirect approach of getting the mask of the subject, blurring the entire photo, and then adding the subject back on top. For instance, what if you just used the image segmentation mask to identify all the pixels of the background behind the subject and just directly blur those pixels? Well, let's zoom in a bit to see what might happen. The thing is, the way the blurring effect works is kind of like dipping your finger in water and then moving it over a watercolor painting to get the pixels to mix together. So if you apply the blur somewhere here, that's fine. But when you try to blur the parts of the background that border the subject, which you don't want to be blurry, then you'll end up blurring the pixels of the subject as well. So if you do the recommended method that you saw earlier, this helps you to make sure that the person in the photo doesn't have a blurry outline around them. Oh, and one more thing. You can actually try out image segmentation yourself by going to Meta AI's website. If you start from the Meta AI chatbot site, you can click on the left-hand menu and then click on AI demos. The AI demos page includes a section called Segment Anything. It's currently version 2 at the time that I'm filming this. So let's click on that. Then I'll click on the button Try It Now. It starts out with a default video that's about 10 seconds long, but I'll go here and click on the button that says Change Video. And there are other videos to choose from, but I'm going to drag and drop a video of my own. Note that for any video that you upload, it will show about the first 9 to 10 seconds of it. So I'll go ahead and click play and take a look at the video. Now I'm going to pause the video so that I can click on an object to segment. And in this case, I'll click on this emoji ball in my hand. It gives me the option to add more mouse clicks to define the object that I'm interested in. But this looks pretty good, so I'll just go ahead and click on the button here that says Track Objects. After a few seconds, it starts to play the video again, and you can see that the emoji ball is being outlined by a blue line. So if you click on the button that says next, it gives you some options for things that you can do with the object that you've now segmented. For instance, you can click on erase and then gradient, and you can also click on pixelate. If you click on spotlight, it looks like it's outlining the emoji ball. If you click on burst, it looks like this, and you can actually click on emoji. So in this video, it's actually replacing this emoji ball with an actual emoji, and you can cycle through a couple different emojis. That's pretty cool. You can also update the background, and it would only affect the background and not the objects that are segmented. So I'd encourage you to try it out for yourself. Maybe you can find a fun video that you'd like to use to practice image segmentation. Coming up next, what if you took a picture of something that has text in it, like an outdoor sign or a restaurant receipt, and wanted to be able to copy that text into a text message, for instance? Let's look at how to do that next. Have you ever picked up a receipt or a brochure or seen a sign on the wall and found yourself typing the text into your phone? What if instead you could take a picture of it and then let your phone get the text from it for you? Let's take a look at optical character recognition and how it lets you do that. Let's say you took a picture of a sign that you thought was interesting and you want to send it to your friend, Frances Coe. Frances replies that she can't read what the sign says and asks you to type it out. So you could try to type it out by hand, but then you remember that you can use computer vision on your phone. So if you're using Google Photos, you can click on the lens icon. Then it looks for parts of the image that look like characters of a language, in this case English. Then it lets you select the text that you want to further process. So then you can click copy. Then you can go back to your message to Frances, paste in the text, and send it. So this kind of computer vision task that looks for characters of a language and attempts to identify and recognize those characters in order to output regular text, this is called optical character recognition, often shortened to the acronym OCR. So what is OCR doing? The software identifies a bounding box around each part of the image that appears to contain a character in a language. Then, for each bounding box, it classifies that as one of those letters. So optical character recognition is actually an application of object detection because it's first localizing where the text appears in an image, and then it's identifying whether it's letter A, B, C, D, all the way to Z, as well as punctuation like commas, periods, dollar signs, and so on. So I'd like to go back and point out one thing you might have noticed. The text that you got from optical character recognition looked like this. And you can see here, the text doesn't seem quite understandable. First, there's this line, Lee Wood, walk of F, and below that, just Holly. Let's go back to the image and take a closer look. If you zoom in, here's part of the image that the software is having trouble with. The text is written on the inside of a circle. Here you can see that Lee Wood Walk of Fame, and here is Holly. So why do you think it output the text like this? Well, most text, like in a document or a book, is written in straight lines. And for many languages like English, text flows from left to right, then top to bottom. So it looks like the OCR software was detecting text from top to bottom, and it assumed that Lee Wood Walk of F was on one line, and the next line below that was Holly. And so one common theme that you'll see throughout this course is that even though AI-enabled software can do pretty cool things, you as the user and the human still play an important role in checking whether the output makes sense. So it's still up to you to make adjustments as necessary. The other point I'd like to make is that when something doesn't work, it might be a chance to learn. For instance, when something like this isn't working quite right, if you can figure out why it's not working the way you expect it to, then you might get a better understanding of how this application or this software works and how you can use it. Another scenario where you could use optical character recognition is when you take pictures of your receipts after you go to a restaurant or a grocery store. You can use OCR to extract the items that you purchased as well as the prices that you paid for them. And what if you're traveling and you took a picture of this sign at an outdoor food market? This app has another button, Translate, and it looks like it performs OCR on parts of the image with Chinese characters, then translate that text into English and overlays the English on top of that. You'll learn more about machine translation later on in the rest of this course. You can also apply these computer vision tasks that you saw in the previous couple videos on your computer inside a web browser. If you use Google Chrome web browser, you can open up the menu on the top right and then click on Search with Google Lens. Select the area you want to search or extract text from, and you can copy that text. You can also translate that text and select objects and images to search as well. Coming up next, I'll share some tips on why taking a break may help you with your studies and your work. So please take a short break and then check out the next video to see why it's good for you.